get started with the today's user group meeting, and for me it's a pleasure to get started with the very first session. So I can.
Hi, sir.
Thank you so much. So I wanted to see the energy in next 40 minutes of my session. I'll just walk you through some roller coaster, but without any nausea. My session is mostly based upon, I have did a collection of everyone who's have started the learning PostgreSQL, who is in the mid of journey of PostgreSQL, and who are the experts. So tell me, who are the experts in this room for PostgreSQL?
I wouldn't consider myself as an expert. Just word and next one.
Just for the sake of the race. Yeah, I mean, it's everybody learns. I have started my PostgreSQL journey 8 years before, and I still consider myself as a learner. Every day and every PostgreSQL folks I speak to, I learn, every time a new thing. So here I have brought in a few of my experiences, which I have worked in my earlier issues with customers or in my experiences. Hope it will be useful for you. So let's walk you to the agenda. I'll talk a little bit about the performance tuning approach, what it should be. It is in general in all the databases, whether it is a PostgreSQL or anything else. Whether you agree with me or not, I also have that perspective. And then a little bit of very basics. This is for those who have started their PostgreSQL journey recently. So those who are already in a mid, or those who are considering themselves as an expert but haven't raised their hand, please don't mind. There are a few fundamental slides. Please bear with me. But I'm sure there are some case studies which I'm presenting here at the end of session with which I have tagged as a real world cases because I have worked on those issues earlier. And what was the resolution and root causes? And of course, everybody needs the best practices, as a glass of breakfast with Horlicks, something like that. Okay. So I'll take a pause here and see if there is any feedback on my voice or anything that you would like to modify, amplify, anything. Very good? Good. Let's get started. Okay. So I know every one of you are relevant to database field, and what do you feel when you get to work on a performance tuning issue? Is it like you every time work when you get a 7 ticket, or you get some kind of a high severity ticket, or you initiate yourself something? The answer is both. It depends also. But answer is both. Why? Because it also depends upon how you want to manage the entire ecosystem, where proactive tuning also comes into the picture. Because you do not wish to go every time with surprises. And that's why you keep on doing a proactive tuning. And that includes a lot of things like both of these approaches, whether you are doing a reactive tuning, means when once you get to know from application team walks to your room and say, hey, the MySQL, which was running 0.01 millisecond, it is no longer running, it is running in the minutes. And you start doing that. But instead, you keep monitoring. If things goes wrong or started getting wrong, you get those traces. And you start acting proactively is where the proactive tuning comes in. And now, with a lot of infusion of AI/ML, a lot of infusion of generative AI, this proactive tuning is booming. So, why I have put this is because as a DBA, I have worked in my earlier career a lot of very hardcore DBA for Oracle and other databases. This is every time my expression was, if somebody was telling me that you should do the proactive tuning, right? Nobody wants to do the proactive tuning in those cases, but now this is actually the requirement as a coming, because you want to catch hold of issues before it happens. And that's where it gives you the most better customer experience, and of course what we call as customer obsession. Well, I would say, whether you agree or not, that tuning is an iterative process. Let's see how. This is my thought process. So what we start with is analyzing, right? What you analyze is the SQL, and eventually, as you analyze, you test it, and of course, you tune it, and this is what the cycle goes around, the SQL that you run on database. But do you think that just SQL is only the things you tune? There are a lot of things around it. So for example, the SQL selecting the data from an object, whether it is going through the table using the index or not, or what kind of indexing, there is a lot we can talk about it. But what you analyze is the objects, the logs, and in PostgreSQL there are specific way you consider generating the logs as well. For example, slow logs, right? This is one of the things that you want to capture if you really want to see that if there are certain SQLs which are crossing the threshold, their execution time, you want to capture in the log with all its details and something like that, right? Now, when it comes to the instance tuning, there are a lot more things you do, right? How do you do instance tuning? It is about the parameters, it is about the catalog that you select and see how your instance is performing. But when it comes to the testing, right, there are a few more things that you do. You do a benchmarking, right, for a particular SQL using what? pgbench. And we also have a PG tab, which is basically nothing but a test any, it follows test anything protocol. So you can, PG tab is basically a tool to write a unit testing for an application without going into the application domain. It's open source and you can use this. The PG tab is widely used when it comes to the unit testing. So you don't have to, let's say application is getting written in Node.js and you're not willing to do a unit testing in the Node.js. You can write in a separate domain language offered by test any protocol. Do you agree? Or do you have this expression? Do you agree?
Yeah.
Okay, thank God. It means I have to remove this. Okay, so next couple of slides, just hold on. I mean, those who are PostgreSQL expert, I know they are waiting for the actual case study. What are those issues? How did you resolve it? Come on, man, I want to know. But I want to take you to some basic things, right? Some basic extensions that might be helpful in your performance. You should know it. If you don't know it, if you know it, please ignore it. So the first set of PostgreSQL extension I have chosen, which can help you in a performance tuning, is pgpartman, free space map, reback, buffer cache, and prevom. And I have again a huge list. I'm not going into every one of this, but some of the important things I'll discuss. These are helpful in exactly doing your SQL tunings, right? So this is just a curated list. I might be missing some extension. I would love to take your feedback after the session. I should include that also. But given the 40 minutes of time, I'll just walk you through some very important things. Now let's get started to the pgpartman. Pgpartman is helpful in tuning your SQL as well as instance. And what it does is, basically it automates your table partition. Those who have worked in the PostgreSQL 10 and before, those know the pain of how we were managing the table partitioning in PostgreSQL, and it does a lot better management for that. So why do you do for a table partition? When your table segment is unmanageable, you basically want to divide and rule the table, right? So it gets you the flexibility of how you can do a customizable of partitioning, and you can do a data maintenance. You can basically create the partitioning so that you can archive the data as well. It helps you to archive the data very easily. Now this is the example that you can partition the table and you can decide whether you want to do a monthly partition or a daily partition and things like that. Now what if you create a millions of partitions? Can you go on creating the partitions and partition? Is there any limit? Is there any threshold that you should not create that many number of partitions? Have you seen any kind of that issue? So the question is the PG department is always your friend? No. I have seen certain issues that comes with a high number of partitions. I would like to share those issues. If your table have too many partitions, right? Because there is a lock management happens when session selects the data across the partition. Of course, if your query is doing partition pruning, it makes a lot of sense to have a lot of partition. But if not, it's going to have a lot of locking condition because the multiple session must be reading the multiple partitions. Now, what are the potential issues? I mean, something like extended, you will be having extended planning time. And if you look at the explain plan, in the bottom of the explain plan, you will always have how much time the optimizer is spending in planning and then execution, right? So, given that, if you see there is a steep, increase of the planning time, it might be the root cause might indicate that you might have a lot of partitions. The relevant PostgreSQL weight is you will be getting a lot of IO data weight event and the log weight events. And what tools can help you is something like PG start activities, PG badger. I'll talk about PG badger in a later slide. And of course, the main thing is explain analysis. Now, the very short-term fix for this kind of an issue is, I know a lot of people you might have seen this issue, but this is something like you have to reduce the need of the scan to the multiple partition. Probably it's a very annoying question for an application developer when you say that I need a short-term fix for so many partitions that I have in my table, right? And that's a difficult thing. But the actually is you have to go and change the design, the way you are partitioned, and you have to change the way you have thought that you are holding the data in so many partitions. What you have to do, you have to first of all reduce the partition maybe by archiving the data, or you might have to change the way you are partitioning maybe from weekly to monthly or something like that, that each partition can hold more data. Probably you want to reduce the number of partitions that you are keeping in the table. Okay, let's go to the free space map. PostgreSQL keeps the free space map to identify what blocks can accommodate the insert data, the new data, right? And it is block by block, in form of the binary tree. It is written in a free space map files. So to get a view of that, this is the extensions. So if you can see the example, the example that is shown in the middle of the box, it shows for a particular block how much free space exists, how much free space map is existing. And in the table, you can basically select what all blocks has how many free space. Now you might be using this view to detect also that do you have a lot of defragmentation, or you have a lot of fragmentation, right? So do you need to do defragmentation? And how do we do defragmentation? There are a lot of ways, but the safest way is PG defragmentation. Well, you need to detect whether you really have that or not. Don't unnecessarily use it. Okay, so the example, what I'm quoting here is you can start the repacking on one single table, or you can do the repack for an entire database. Only you need to keep in mind that, of course, it gives you to get away from doing the, a full vacuum, but it comes with a lot of locking mechanisms that your session, multiple concurrent session might not distribute. Okay, moving on. We also have, it might be helpful to view what is the content of your buffer cache. Primarily, buffer cache uses to, you want to hold some data in your buffer so that you can reduce the I/O. So suppose you have 100 tables, and one or two tables are very frequently selected. Now you want those table data to stay in buffer cache, shouldn't get leased out. So see how many. With this view, you will be able to you should be able to see, how much table data do you really have in the buffer cache for a particular table. For a particular schema database, you can actually change this query to look at it a different way. Now the point is, what if you find that your table doesn't have enough block stored in a buffer cache? What you can do about it? You really want, right, those tables to be. So the solution is PGP-ROM. So with PGP-ROM, your application expects what? That it should get data directly from the buffer. So I think this is the moment of, I want to capture that your application should expect that everything should remain in a buffer. I think the main crux of this that you want to cache, you want to warm the cache with your highly selected data or frequently selected data, and you want to write the data back to the buffer as soon as data changes also. So mostly I have seen, this is mostly for not very dynamic table. Don't experiment with a very dynamic table. It is a little bit of dynamic table or maybe a static table, and mostly people does it like they will start the PostgreSQL and try to reform those tables. Probably it is more towards the OLAP use cases. Now, next set of extension, I have a huge list. I'm not going to every list. We can discuss in of the sessions if you are interested. But I'll start with auto explain. So auto explain gives you a capability to trace your SQL in case if you think that you need to trace the plans for a particular SQL, which is whose execution time is greater than X milliseconds. So this is the way you configure, and it starts capturing the SQL plan. And I have also written sometime back a blog on Medium that there are multiple ways, and this is one of the way you can trace your slow SQL statements. If you have a problem, how do I trace my SQL statement? This is the best way I have seen. Okay. Do you get this question as a DB architect? I mean, you have designed, you have architected the architect. Now you are questioning me. What? Okay. So once you start getting the problems and issues, I think PG stat statement is an extension that gives you a better view of what exactly is happening as an activity in a database. And these extensions you should widely use to analyze, like you're doing the query monitoring. I mean, there are a lot of queries in a different way you can create, but I would highly recommend to get into detail of this extension to see what different things you can select. Here in the example, I have seen that you want to see that what are the top 10 most time consuming queries. So this is another way you can select these slow signals. Okay, PG hint plan. Why do we use it? Now when optimizer doesn't follow what your mind says, you want to control the optimizer, you want to provide a hint into your SQL statement that, hey, I want to run hash selection, instead something else is going on, or a nested way of selecting the data is going on. So you can influence with the help of partitioning. The example says that you are influencing the optimizer with the leading index scan and the nested blue hints. Okay, one moment before I go there. So there are lot of others, I'll just give a one-liner about it. Hypo-G is a very recently introduced extension where you create a hypothetical index, actually, and you see what is optimized responses, right, before you actually create it. So this is helpful in your experimentations. Similarly, you have PG stat K caching. This is helpful when you want to generate a CPU level or IO level stats. PG qual stats. This is the extension which you can use. What it will do is it will basically analyze the where clause and the join clause, and it will recommend you what sort of index you should create on your server, because it will analyze all those queries. Similarly, weight sampling is a little bit of more details that you want to see on top of what you can select from PG stat statements. You can actually sample, let's say, 1 minute of stats or 1 hour of a stat with weight sampling. It's very helpful in a very deeper performance tuning where you want to bucketize the weight events into a different time context. Now, I have a couple of two more, PG Badger. So, PG Badger is when you want to see a visual representation of your log files, right? PostgreSQL creates a lot of log files where it generates what's happening in a database basis, but you want to generate a visual representation. PG Badger is actually helpful in generating that. It is really helpful to see your log files, but you need to keep your log file at one single place because you can actually generate a report for more than one log file with a wide library. You can see in the example. Okay, so this is one of the screenshots that I've taken which shows that how the auto vacuuming action is happening in the last 5 minutes, and it is generated out of the log files. PG Hero, I'm not sure how many of you are aware about this. This actually does online query to your PG catalog, and the result of those PG catalogs show you graphically. So this can be helpful when you want to see how much live connections you have, how many concurrent connections you have, what are the different maintenance reports and different tabs. This is a very bogus report I have in a screenshot. I'm sorry for that. I should have a very populated report which might be helpful for you. And being the open source community, list goes on. There is a lot of. Okay, so let's start with the most awaiting section of this session is what are the case studies, what are different performance tuning case studies I can show you. Tell me, true or false? True or false?
True.
True. If I say a PostgreSQL is an immutable ledger kind of a database, do you like it? Yes. I mean, no row once inserted is ever going to change at a physical level, right? And it sometimes creates issues. So let's get back to that issue. What exactly? So there was an issue that after migration from Oracle to PostgreSQL, there was a frequent executed update statement was getting slowed down, and what we got as a task was to improve that update statement. Now, these update statements were belonging to a particular table. Now, what we did is, of course, our first thing is to analyze the SQL, and we checked what were the indexes, if update statement is really using indexes to search those rows or not. But if there is an issue in update, you should really check fill factor. Those who are coming from Oracle background, fill factor is equivalent to the PCT-free space. It's a space that you left over in the block so that update statement can update the rows. Now what we find is that the fill factor was 100%, and the issue was resolved when we changed the fill factor at a table level from 100 to a little bit lesser value, which is 85. And it has also reduced the redo log generation, and we have improved the update statement 40%. Now, I don't want to end the story here. What exactly you should see and how it should be analyzed, let's see that. Now, if you look at this figure, this is actually a block state, one single block for PostgreSQL. So, if the all the row starts from the bottom, and the row, the block header have the pointer to all those rows, and the fill factor configuration basically leaves the space empty, and after that, no other insert statement will actually add the row into that block, and that is how update statement can make a room for extending the data which is already in the block. Now, there has been an enhancement over a period of time, but previously there was a lot of struggle before to the PostgreSQL 9, because PostgreSQL 9 introduced a concept called hot updates. It's not hot and warm, it's a heap only table. What is heap only table? Let's understand. Now let's say if you have a table which contains two columns where ID and data is there, I'm going to run this update statement called update set data equals to ABC where ID equals to 3. Now, what will happen without update? If I do this update multiple times, same row with a different value, let's suppose, and if I have an index will start to point, and if I do multiple updates, it's keep on adding the rows, right? Because PostgreSQL doesn't overwrite the existing row. Each updates will actually going to insert a new row. So the index will eventually be having the multiple entries for the same value until it gets vacuumed. Right? You see there, the 3 value, it has been updated multiple times. So 3 row is inserted in one block, the other 3 is inserted in another block, and index is eventually having the pointer to those. Now, when you go to hot updates, in hot updates means when you have a fill factor, it is going to place your next update in the same block, and it will have an internal pointer from the same block to the new row, but index will not have the extra pointer for that. And this is called the hot updates. And this eventually reduces a lot of contentions and slowness in the sequence. Now, who will remove this row? The comparison between these two. Without hot, your rows from the index and tables will be, dead tuples will be removed only because of vacuum. But in hot update, vacuum is not required. Any subsequent SQL session who's selecting the data from the same block will clean this. So that is how it will improve, but there is a condition you should know when hot updates happens. So the hot updates happen as long as you have a free fill factors, and you are not changing the index, the column which is already indexed. So I would highly recommend you use the fill factor and see if you can increase your speed of the update statement using this method. Now the next case statement is, we got performance issue on queries which was regressed by the 90%, and the developers were stuck for multiple days. They were doing their own research as usual. They didn't inform us very early, and the query was relevant that it was a little bit of complex query with 6 tables and a lot of joins, and of course we got a task to improve the query. What we did is we first analyzed the logs, because they were doing from the 6 days. We dumped everything in a BG patcher and tried to generate the report, and of course with explain, analyze, we kind of see that what is comparison between execution time and learning time. And we see a lot of difference. Learning time was 400 times than execution times. What? If you plan whole life and you don't execute, obviously your life is, I would not say that word. Okay. So, now what we found is, in the recent change history, somebody has changed the default stats from a default value, which is 100, to 8,000. I think maximum value what you can set is 10,000. What it decides is, it decides the level of the prime granular statistics catalogs generates for the day. And somebody did this because they had a problem in one of the query, which was selecting a particular column, and for that only it was required. What they did is they changed it for entire database. it impacted all other tables, all other queries, and the query on which we were working were impacted by this. Now, you can change this setting at a column level if you really require it. Generate for a fine granular level of details for a particular column and leave other database. Don't impact that. Okay, so the result is when we reset this value to a default value, the planning time was reduced from 598 millisecond to 103 millisecond, and query performance was improved by 90%. Now, check on time. Thanks. So, CPU usage reduced from 70% to 70%. Now, let me onboard you a situation where we were getting the poor performance of SQL when the database was migrated from Oracle to PostgreSQL, and CPU usage was also pretty high. I mean, if you, we did a comparison. Same SQL was running on 16 core, and here when it came, it was running 4 times. It was consuming 4 times. So what we got as a task is to reduce the CPU consumption, right? And what we adopted is we identified what were the top CPU consuming queries. Okay, so VG Batcher will help you. There are reports that you can generate from the VG Hero, and there are other tools that from there you can generate the top CPU consuming queries with the help of VG stat statements extension as well. We also validated are there any objects loaded, but I think it was a kind of a very foolish decision, I would say, because we just migrated here. So, but we did just to check it. And then we identified in the execution plan that query planning time was 29 times greater than execution times. This is very uncommon issue. Okay. Why I'm saying this? Don't take this granted that the resolution of this issue will always be if the query time is like this. Because performance tuning is not a science, not just a science, it's an art, right? It could be possible. You need to just take a chance. Now, the fix what we did is, we changed the SQL statement to use the prepared statement. And we fixed this with a parameter called force generic plan. I'll explain about this in a coming slide. But the result is, the planning time of the query was reduced because of this, from 70% to 17%. Sorry, the CPU usage. Now let's talk about what is prepared statement. Do you use prepared statement? So I think there are a lot of people familiar about it, but let's talk about fundamentally what is a prepared statement. So when you don't run the prepared statement, this is the life cycle SQL statement goes through, right? Parse, analyze, planning, and then execution. So I will name this as the unprepared statement. Okay. This is my naming convention, don't take it away. Now what is the prepared statement? Comparison to unprepared statement. What it should be? Any idea? So if you use prepared statement, it goes through this life cycle once, but it never does go back to again parsing and analyze. It might generate a different plan for each execution because parameter might be changed. You can execute the query with different parameter. For each parameter, it tends to change the plan. But it keeps the analyze and parsing away from its life cycle. That's how you reduce it, improve the performance. Now, there are a few things you should know about prepared statement. If you are using prepared statement, you can use PG prepared statement to check what are the things that you are executing and make sure it is not a global statement, it is global to your session. And Deallocate is basically a keyword which you can use to reset your prepare statement to again start a journey from the start. Now, who should use the prepare statement? When you test to execute same SQL statement and want to avoid the parsing and the subsequent step, you just want to do planning and execution, planning and execution, planning and execution. Now, the parameter which influence this, there are three parameters. Force custom plan, the parameter values are these. The parameter is plan cache mode. The force custom plan, what it does is, this is the most aggressive, I would say, configuration that you can do. For each execution, it will generate new plan. So think about it. It might regress the time that is consumed every time it generates a new plan. Force generate plan. You want to run the repair statement, but you don't want to generate the plan as a different plan on every execution. So it fixes the plan, and that is how it fixes the issue there. And this is the default value. Here PostgreSQL documentation says that after it changes the plan after 5 execution, but I have not seen it. It is kind of a heuristic approach. It actually regenerates the plan after 10, 15. It's a random numbers. So what it fixes, when we set the values to the middle, which is the force generic plan, it has reduced a lot of planning time, and that is how it has gained the performance. Okay. I hope I'm not too fast, but in the interest of time, I'll just move on. I'll see if there is any query by the end of the session. Have you seen this multi-exact contentions? What do you mean by multi-exact contentions? Anybody who is aware of this?
Multiple transactions trying to read the same table or same word, same word.
Yes, exactly. There is a concept of sub-transactions, right? Sub-transactions mean when you start a new transaction without ending another transaction that you are already running, right? And this nesting of transaction, called sub-transaction, it's also a pinch of salt. If it goes beyond a threshold, it's going to create a problem for you, right? Because it reserves the memory, the buffer cache, and there's likely chance that your other buffer data will spill down to your disk. Basically, how do we create the sub-transactions?
Calling function within function.
Right, I mean, you start another begin and then you can also start with save points, right? The moment you create a save point, it means you are actually starting another sub-transaction. Or, if you are doing any transaction in exception log. So, like a lot of developers, right, they have to do exception handling. And if you are doing exception handling and you are doing transaction within the exception handling, it's also a sub-transaction. Do you remember? A lot of developers ignore this, and it creates a problem of multi-exact contention. Now, multi-exact contention means for the same row, there are a lot of nested transactions. Is what called multi-exact contention. And example I can show you here. So if you look at the example, we started with a begin statement on a table. There is an insert value, and we did a save point. If you look at the save point, and we are doing a subsequent insert for each save point, and if you look at the, so we have a pseudo column in each table, right? And that shows you that what is a transaction ID generated for that particular transaction. You can see there is a different transaction ID generated for each of those sub-transactions. And if you keep on generating these sub-transactions, you know that it's a finite value in PostgreSQL. Right? It's a head to tail kind of a race we run in the transaction ID. So what issue and recommendation is, the very first problem is, if you don't monitor it, you will run out of transaction IDs in the database. because it's a circular way the transaction ID runs, and tail is approaching the head or head is approaching the tail. I don't know, but the moment they will meet, you're gone. What you're gone? What happens if this happens? Even if you have the rows, even if you have the rows in a PostgreSQL, it won't show. You will lose the data. The second thing, what it comes with the problem is the per session cache. So for sub transaction, there is until PostgreSQL 14, I know I'm not sure if there is something changed on 15 and 16. There is a hardcore value of 64 sub transaction limit to be remain in memory, and if it crosses, your sub transactions is going to spill down to the temp space on the disk, and this will cause a bigger issue. And unexpected use of multi-exit ID means one single row. If you have a lot of sub transactions, think about what condition we have. Let's suppose out of 100 tables, there is one row where everybody is doing a sub transaction. That exactly causes a multi-exit. So, what is the recommendation? Enhance your observability. Check if you really have a sub transaction, and you should always predict and prevent failure. Now, my final slide is, in order to prevent the sub transaction, I would highly recommend that if your application team and you itself is using any ORM tools, implicitly ORM tools creates a lot of sub transactions. For example, JDBC driver, right? It has a parameter called always for committing the data. So every SQL you execute under JDBC transaction is going to create a sub transaction. If you don't end it, you're going to have a chain of sub transactions. So here is a list of all the ORMs that is being used with the names and things. Please check. If you really have the issues, go and ask your application developer, hey, check. Yeah. I mean, you cannot resolve this, right, at the database layer. It is at the ORM layer, they have to configure. So, yes, there is a high demand. I should end the session. I have come to my final slide. Thank you very much. Hope the session was useful for you. And if you have any questions, feel free to touch me on the LinkedIn. This is the bar to connect with my LinkedIn profile.